Hey guys, this is our Calculus ISU, and here we are going to explain about vectors and applications of vector. This is our group of 4 members: Abdullah, Nick, Yang, and Tawas. So let's get started. So, what are vectors? Vectors have both magnitude and direction. Let's say 5 miles per hour is magnitude, which is a scalar quantity, and direction, which is towards the east. And when these two mix together, we get a vector quantity. Before learning anything about vectors, there are some prerequisite skills we need to know that are law of sine and law of cosine. So what is law of sine? Law of sine is an equation relating to the lengths of the triangle to the sines of the angles. For example, let's say angle A is 55 degrees and angle C is 30 degrees. So we can find the value by law of sine, which results in 13.106. Another law is law of cosine. Law of cosine is used when calculating for one side of triangle when the opposite angle and the other two sides are known. For example, we have two known lengths and one angle, so we can find the length of the side of the known angle by using the law of cosine. There are some keynotes that vectors have no location. We can arrange vectors wherever we want, and vectors have no negative magnitude as well. Negative sign only shows direction of vector. And also, we need to know some rectangular components of a force before applications of vectors, that are vertical component and horizontal component. For example, a car is pulling another car on the slope which is 20 degrees to the horizontal. The tension between these two cars is 300 newtons. So we can find the horizontal component Fh, which is equal to F implies to cos 20 degrees, while the vertical component Fv, which is equals to F implies sine 20 degree. The answers will be 281.9 Newton and 102.6 Newton respectively. Okay, we can start our applications of vectors. Let's say there is an airplane traveling with a true bearing of 50 degrees at 800 kilometers per hour. So, wait, what is a true bearing? True bearing is the angle measured in 3 digits in a clockwise direction from the North Pole like a compass. Now, we can solve our flight problem. So the plane is moving at 50 degrees from the north with the velocity of 800 kilometers per hour, and the wind is blowing from a bearing of 120 degrees at 60 kilometers per hour. So, what's the resultant velocity of the flight? At first, to find the resultant velocity of the flight, we can add the airplane velocity and wind velocity together in a head-to-tail method. This would give us the resultant velocity of the flight. So, we can find the resultant velocity by using law of cosine, and we get 781.51 kilometers per hour as a result of magnitude. For the direction, we are going to use law of sine to find the value of theta, and we get the true bearing by subtracting theta from 50 degrees. So the final answer will be 781.51 kilometers per hour with the true bearing of 046 degrees. There is one more method to solve the flight problem. This is algebraic vectors method. From the diagram, we can find the vectors of airplane velocity and wind velocity respectively, and then combine these two vectors to get the resultant velocity, and we can get the magnitude by taking out the square root of the combination of square of x and square of y components of the vector. For the direction, by using tangent rule, so you can get the direction as well. The answer is exactly the same as a result from the previous method. Now you know how to solve the flight problems, so we can move to the tension problems, which is also the application of vectors. Okay, let's move on. Let's say that 2000 Newton block is hanging from a wall with two cables with different angles. How do we find the tensions of these two cables on that block? We all know that vectors have no location, and we can place vectors in any position, and we can find the tension of each cable by using law of sine, because it looked like a half of a parallelogram followed tail to tail method. Now we got the answers of T1 and T2 as 1843 newtons and 1630 newtons respectively. Finally, we are done with the applications of vectors. You guys know who we are, right? So we would like to share an interesting concept of vectors with you guys. There are vectors in 2 dimensions and 3 dimensions. So in this picture you can check there are 3 types of dimensions of vectors. In 2 dimensions, there are 2 perpendicular lines reference x and y. In 3 dimensions, there are 3 perpendicular lines as reference x, y, and z. After a brief explanation on vectors dimensions, we move on some properties of vectors. Let's say a, b, c are vectors that may be in 2 dimensions or 3 dimensions, and d is a scalar. So vectors have commutative property, which means a plus b is equals to b plus a, and vectors have associative property, which means a plus b plus c is equals to a plus b plus c. And there is also one distributive property when d is multiplied by a plus b equals to dA plus dB, and there is a unique vector 0 such that a plus 0 equals to a for every vector a, and if u implies 1 with every vector, we still get the original vector. For example, 1 multiplied by a, we still get a. After learning about vectors, you can now apply the concepts on different vector equations. We will explain the details of equations of vectors in 2 dimensions and 3 dimensions in our next ISU video. See you then!